This figure is interesting for a couple of reasons. First, let's look at the anatomy. On the x-axis, you have the years from 1850 to 2005. And then, on the y-axis, you have global carbon emissions in million metric tons. The scale goes from 0 million metric tons to 9,000 million metric tons, which is another way of saying 9 billion. At the same time, there is another y-axis of global population growth in millions. Don't get confused by the 1,000 millions. It starts with 1,000 million, which is equivalent to 1 billion. The upper end of the population scale is 8 billion, or 8,000 million. In order to make the viewer see the difference more clearly, it's color-coded with global population in blue and emissions in red. Around the year 1850, the scale was made such that the global emissions and global populations converge, and then you can see what happens from there. That's how the scales are made. Around 1900, we had 1.6 billion people. If we were to continue the blue line to 2011, specifically we believe October 31st, you would see that we hit 7 billion people. Currently, we have about 7.7 billion people. At the same time, we see the carbon emission line also rose from less than 1,000 million tons, or 1 billion tons, to about 7,500 million tons, or about 7.5 billion tons. We are currently at about 9.75 million tons, or 9.75 billion tons, and that's metric tons. Last week, we learned that the x-axis is the independent axis, and often the one that depicts factors that have an effect on something else. So here, of course, that is ridiculous. It's not just the passing of time that causes emissions or populations to grow. This graph shows how emissions and populations grow over time relative to one another. It's a different way of looking at the data. What we see here is that carbon dioxide emissions are growing at a faster rate than population, which can be very informative and begs additional questions like why? The y-axis is the dependent axis. Here, that doesn't make a lot of sense because our x-axis is time. If we were to plot global population on the x-axis and emissions on the y-axis, we would be implying a dependent relationship. But the data being shown is correlational, not causative. So we're not showing that graph. That's why it's graphed this way, to emphasize the relationship. But to be clear, we have an enormous amount of evidence showing that humans are causing global climate change through carbon emissions into the atmosphere. But these data are not that evidence. They just show the relationship. Throughout the semester, we will be looking at the evidence in more detail. Here's a graph I made from an old class. It shows the number of hours studied on the x-axis, or the independent axis. On the y-axis is the dependent variable, or the student exam scores. It makes sense that a student's exam score is dependent on the number of hours they studied, but it doesn't make sense the other way around.